Okay, so we're going to do Chapter 11, Number 2. The Sea Wharf restaurant would like to determine the best way to allocate a monthly advertising budget of $1,000 between newspaper advertising and radio advertising. Management decided that at least 25% of the budget must be spent on each type of media, and that the amount of money spent on local newspaper advertising must be at least twice the amount spent on radio advertising. A marketing consultant developed an index that measures audience exposure per dollar of advertising on a scale from 0 to 100, with higher values implying the greater audience exposure. If the value of the index for local newspaper advertising is 50 and the value of index for spot radio advertising is 80, how should the restaurant allocate its advertising budget to maximize the value of total audience exposure? A, formulate a linear programming model that can be used to determine how the restaurant would allocate its advertising budget in order to maximize the value of total audience exposure. And B, develop a spreadsheet model and solve the problem using Excel solver. So what we did first here is we're going to say, okay, let N is be the amount spent on newspaper advertising, and R is going to be the amount spent on radio advertising. So the max is going to be, as far as our uh, total audience exposure, that's what we want to maximize. So it's going to be 50 times whatever our N is plus 80 times whatever R is. So that's going to be the max value of the total audience exposure. And what we have is the newspaper plus the radio budget is going to be equal to $1,000. The N is said is at least 25% of the budget. So at least 25% of that is going to be 250. So N is going to be greater than or equal to 250, which is the newspaper part. And then R is going to be also greater than or equal to 250, and that's the radio minimum part. Then it said the newspaper was going to be at least twice the radio. So that's going to be N is greater than or equal to 2R. And all we know for sure is the N and R are both going to be greater than or equal to 0. Okay. In fact, they're going to both be greater than or equal to 250, but that's beside the point. So let's go look at a model. So what we need to do is set up a model like we normally do. And so we're going to have the Sea Wharf restaurant. We're going to have parameters. And then we're going to have an audience exposure index per dollar. So that's just going to be 50 for newspaper, 80 for radio. The minimum allocation is, again, 25%. Our advertising budget, they said, was 1,000. And so then dollars allocated for newspaper and radio, that's what we're looking for. And the total spent is going to be the sum of those two items. Now, remember, the total exposure index was going to be a product, and we're going to use the sum product, and we're going to take the B6, C6 here times the B14, C14. So it's going to be the 50 times the N and 80 times the R, basically like we had over here. That's what we're going to do, and that's going to be what our total exposure index is. So what we need to do really is find those values. And so we're going to use the data solver. And so we go up here to data. It looks like it's already clicked, and we're going to go to solver. Now, the nice thing is I typed this in earlier, so I wouldn't have to actually go in and do it, and it actually saved it. So I was happy about that. Here, this is a set objective. So our objective we're setting is this total exposure index. That's what we want to maximize, and that's what we're doing here is maximizing. And we're going to change it based on, now we got to change that again back to here. We're changing it based on these two variables, the newspaper and the radio, how much we're going to allocate and money for each of those items. And our constraints are basically our constraints we had over here on this side, where, you know, N plus R is equal to 1,000. And so all these are going to be into that. So let's go back to our model here. So basically this one, the newspaper money is going to be greater than or equal to 25% of the 1,000. So 25% times 1,000. And then the B14 is going to be 2 times or greater than or equal to 2 times the radio. And so it's going to be greater than or equal to 2 times the C14. Now C14 is just, again, going to be greater than or equal to the 25% times 1,000. And then the E14 we know is going to be less than or equal to B9. So that's our budget. So it can't be greater than that, so it has to be less than or equal to that. All right, and so what we're going to do then is, and the way we do that is, oops, looks like we clicked the wrong thing here. Okay, hopefully it'll delete. Okay, maybe. Okay, that's right. And what we need to do is, if we ever need to add more, we just click the add. If we ever need to change, we just change. And so all we do is, like, if we wanted to say add something, we could just say we were going to add, you know, this is going to be greater than or equal to this. and we could add it, and then we could add another one, or we could just say okay, and then that adds it in there. Okay, but we really didn't need that, so we're just going to go ahead and delete that. So that kind of shows you how you can add something. We can delete it. We can change it by clicking change, and then it will let us change that. And we're going to use this solving the simplex LP method. And we just click go once we've got that done. And found a solution. All constraints and optimality conditions are satisfied. And so let's keep that solver solution. And so we'll just say okay. And so what it says is, we're going to spend $666.67 on the newspaper and $333.33 on the radio. Our total spent was $1,000, and our maximum total exposure index was 60,000. So that's going to be how we solve this problem. And so now we've formulated the linear program here, and then we've actually solved it using this. So hopefully that will help you at least get started on this chapter.